Well, welcome all my AP Calculus lovelies. Here we go. This is my first video that I'm going to make for you, all about a visual introduction to limits. This one is going to be one of the longer ones, so as I make this, you can pause it at any time, continue with your notes after you take a break, do whatever it is you need to. There's a lot of things that we are going to introduce here. As a visual way to look at limits, but also we're going to review a lot of algebra stuff that you have seen before, but you might not remember how to do. So we're going to begin, first of all, with a short activity. I'm going to present my screen, and once I present my screen, I'd like you to pause the video and then try to do this activity on your own first. Okay, so I'm going to present my camera, and you should be seeing here on my IPBO screen. Okay, so right now you should be seeing a piecewise function. So what I'd like you to do is pause the video, look at and draw this in your notebook. I'm setting up the page as I have set up here, and then draw this piecewise function. Okay, so go ahead, pause the video and start. Now, welcome back. I know that at this point you should have attempted to draw this on your own, but I am going to go through and review how to draw a piecewise function. So first of all, if you remember from pre-calculus last year, the first thing that you need to know is you need to look at your restrictions, okay? Your restrictions are defined by the x values that are right here. This is telling you these are your restrictions. This is telling you the x value that is going to be places where we're going to have things happening. So in this case, you notice that it's x is less than 2, x equals 2, or x is greater than 2. So on my graph, I'm going to go to x equals 2, and I'm going to put a dotted line, a vertical dotted line, because things are going to happen at that x value. Now, some things are going to happen below x equals 2. Some things are going to happen greater than x equals 2, and some things that are going to happen right at x equals 2. So put your vertical line in to show where your restrictions are. Now, the second thing you have to do is calculate values and sketch the line. I should say lines, plural, okay? Now, sometimes those lines might be curves, sometimes they might be just lines, but you do need to calculate some values and sketch the line. So what I like to do is I like to make just little tables of values, and I notice for this first one, the one that is below 2, okay, I have to use this equation. So the equation I'm going to use is 6 minus x for any values that are less than 2. So I'm going to start at 2, then I'm going to go 1, and then I'm going to go 0. Now, something you should remember, or you should know just by looking at this, is anytime it's 6 minus a single x, that's a line. So 6 minus 2 is 4. 6 minus 1 is, 6 minus 1 is 5, yep, and 6 minus 0 is 6. So I'm going to plot all of those values. So I'm going to go 1, 2, 3, 4, 5, 6. So I know at 0, I have a point right there. I know at 1, I have a point right there. And I know at 2, I have a point at 4. So on this side of the graph, I have a line that goes downward all the way to x equals 2. Now, the second thing you should notice is we have a restriction at x equals 2. So I know at x equals 2, this just says the value is 4, okay? So I'm going to go over to 2, and I'm going to go up to 4, and I'm going to put a dot at 4. It's kind of nice. It actually hits right on the point that the other graph is. So it's just going to kind of fill in that space. Now, let's take a look at the other part, okay? So the third and final part is we have x over 2 plus 3. And I know that's for any value greater than 2. So I'm going to make a table of values right here, and I'm going to use x over 2 plus 3. But I have to use numbers greater than 2. So I'm going to start at 2, and I'm going to go to 4, and then I'm going to go to 6. Reason I'm doing that is notice that it's x divided by 2. So I'm going to pick even numbers so I can very quickly calculate the values. So 2 divided by 2 is 1, plus 3 is 4, okay? 4 divided by 2 is 2, plus 3 is 5. And 6 divided by 2 is 3, plus 3 is 6. Okay, so I have to go, here's 2, 3, 4. And at 4, I have to go up to 5. And then I'm going to go 5, 6. And at 6, I have to go up to 6. So here is my piecewise function or a graph of this piecewise function. So what I do have to finally check out, though, is in the end, you do have to check and make sure that your dots are correct. So the last thing you need to do is put opened or closed dots at key points. So notice here, if we look at this first one, it's x is less than 2. If it's less than, that means at 2, the dot, it needs to be an open dot, okay? So it should be an open dot here, but there is something that happens. Notice that all of these meet at the same spot, okay? So this one says x equals 2 is the value of 4. Equals means to close the dot. So because all 3 of them meet here, I have to have a closed dot at 4, okay? Now, we will look at some other graphs later on that show some open dots and stuff like that, so don't be overly concerned if that doesn't make sense, but that is the process. You need to look at the restrictions and know where those are going to be. Put your dotted lines in, okay? So this is going to be those dotted lines. Then you need to calculate values and sketch the lines or lines that on either side of those restrictions. And then finally, you need to put open and closed dots, okay? So that's a review of calculating or drawing the graph of a piecewise function. So now let's actually get into some calculus, okay? So now we are going to define what a limit is.